Welcome back to Do It Garage. Today we're going to be figuring out why the air conditioning isn't working in my F-150. Let's show you what's going on. So this here is my 1997 F-150, and the air conditioning worked great years ago, but I just bought the truck back about a month or so ago, and I cannot seem to get the compressor to kick on. The compressor is down there. This is the 5.4 Triton. The compressor is down here on the bottom. So the way that this works is that when you turn on the air conditioning in the cab, it sends an electrical pulse to the computer, which sends an electrical pulse through multiple sensors before going to an electronic clutch on the front of your compressor. So the way that works, the stream of it is, comes out of the comes out of the computer, and then it comes right down to here. This is a high pressure switch on your AC, and then if it makes it through there and the high pressure seems okay, it goes back here to your low pressure switch, which is right back here. You can see these cords going in. This is mounted on top of your what's called your accumulator, which is this big metal can looking thing. And as long as the low pressure switch says that it's okay, then it will go ahead and send electricity down to the front of the compressor to the clutch, and your compressor kicks on. So right now, my compressor won't kick on at all. That can happen for multiple reasons, one of them being lack of Freon. So normally when I see people with this problem, what they'll do is they just instantly start throwing Freon into the system. But that's not necessarily the case. So let's start diagnosing this and see what's going on. This is our high pressure sensor. So as soon as that is clicked on your AC in the cab, the electrical should come from the computer to here. So we should be, with the key on, we're going to go into the cab, we're going to turn it to AC. The truck doesn't need to be running. All we're testing is the electrical impulse here. We should read 12 volts. And we should, as long as the computer and everything's fine, we should be getting 12 volts to our high pressure sensor here. Let me get you a better idea of what's going on. So we're going to check our switch here. So the way to do that is we're going to have to pull it off of the sensor. On this one, it has a little clip that you actually need to pry out. Normally you push these in and you pull them off. This one you have to pry it out and it pops right off of there. There we go. Okay. When you get it off, you should be left with something that looks like this. You can see there are 4 little holes. It's a 4-prong switch. And then this is actually coming off the wiring harness. What we're going to do is we're going to go in the truck. We're going to turn the key to run. It doesn't need to actually be running, just in the furthest position before start. And then we're going to turn the AC on, which should, in theory, engage the clutch on front of the compressor. Our switches are all on. We have our ohm meter here. We're going to turn this over to 20 volts right over here. Well, all we're going to do is we're going to take our red lead. We're going to test the 4 prongs here. We're going to take our black lead and run it over to the negative on the battery and see what kind of reading we get. So let's start at the top left. Yep, look, right there. We're reading 11.75. That's a little low, but that's still, I would consider that 12 volts. Check our other ones here. I don't believe the rest of these should be getting power. It should just be the one. Okay, so we at least have 12 volts to this switch. That doesn't necessarily mean our switch is okay, but our computer and all of that is sending power to our high pressure switch. So that at least eliminates a lot of the bigger issues as for a computer replacement or anything like that. Let's move on and do the same test on the low pressure switch, because as long as the low pressure switch is getting 12 volts, that means that our high pressure switch is working okay. The same process here on our low pressure switch. This one is a little hard to get off just because it's so contained with all these wires back there, but just be patient, it'll come right off. It's the same setup, a 4-prong switch, and we're going to do our same test. Keep an eye down here and look for 12 volts. Again, as long as we're getting 12 volts back here, considering this is downstream from the high pressure switch, that means our high pressure switch is okay. So we're just going to test here with the same one, touch our negative, and look at that. We're getting the exact same reading, a little lower, but close, on our low pressure switch. That tells me that since we're getting 12 volts here, our high pressure switch is okay, yet we're still not getting it down to the clutch on the compressor to get it to engage. You see, the system is closed, and it requires pressure in there to make it all stay lubricated and keep your compressor and all the components in good working shape. So say you have a leak and you've lost all of your Freon, then that is what that low pressure switch is there for, to make sure that your compressor is not running without lubrication. So you have to make sure that you at least have a base level of Freon or refrigerant in the system to make sure the compressor will kick on. So that's what we're going to do now. In order to check your low pressure, it's going to be right back here on what's called your accumulator, which is this metal can. And you can see it's got this little cap. You just unscrew it real nice and easy. Comes right off. And there you go. And you may have seen one of these at an O'Reilly or Advance, wherever you shop, which is just a little gauge with this clip on the end, which clips right into your low pressure side. It will not fit on the high pressure side. The high pressure is a different size. So the only problem with that, though, is that, if you don't have the engine running, or say you have the engine running, but the compressor won't kick on like this one, is that this, not that it's useless, it's just that it's only accurate when the compressor is on. So if I plug this in right now, the reading that it gave me really wouldn't mean much to me. Also, I hope you can hear me okay. We're getting a little bit of a Missouri rainstorm, and it's a little loud on my metal roof. But anyway, if I just plug this in without the compressor running, it's not going to tell me much of what I need to know. So I need to figure out a way to get the compressor to run briefly while I can check the system and make sure that I at least have a base level of Freon in the system and can eliminate that as my problem. Now, as I mentioned earlier, when you come in here, you're going to have your high pressure switch on the AC system, as well as your low pressure switch right back here. Now, before I did any tests, what I did was I just unplugged these and took a look at the connections. And what I noticed was the high pressure side looked just fine, but the low pressure side had a lot of corrosion in it. So I'm starting to believe that this might be a low pressure switch. This is called a cycling switch on this truck. It's right there. A low pressure cycling switch issue. So what I will do is, because I believe that corrosion in this switch has caused our problem this whole time, is I'm going to show you a way to kind of bypass this switch and very briefly engage the compressor, just so we can check our readings on our dial gauge and make sure we at least have a base level of Freon, and that is not our issue. The reason you want to be very careful with this is that your system requires refrigerant as a lubrication system, and there's also oil in the system. So if you have zero refrigerant in there, that low pressure switch is meant to protect your compressor. If you're going to bypass that, there is potential that if you run it for too long, you can damage the compressor. I only recommend doing this very briefly, and I wouldn't do it to someone else's truck. I'll do it to mine, though, especially this one that's not that expensive. So what I've done is, because I think this was our problem, this low pressure switch, I have unplugged it, and I cleaned it up quite a bit, because when I first undid it, there was a lot of corrosion built up in here. So what I'm going to do is I'm going to go ahead, and I have this little jumper wire. I'll explain a little bit further on this here soon, just to double check that this is our problem. But just to make sure that our compressor engages, because I believe this is our problem, is this switch back here. I'm going to bypass the switch. And what I'm going to do is I'm going to take this wire and stick it into each one of these prongs that has the metal on there, just for a second, and see if our compressor engages. And if that's the truth, then at least I know that all of the wiring in the clutch itself is good, and that will allow us long enough to plug our gauge in and check our pressures and see where we're reading. Let's see what happens here. Okay. Our compressor did kick on. I'm not sure if you heard that or not. Okay, I got that stuck in there. We're gonna take our gauge here. There. With the compressor running, we're reading right at 40 psi. That should be plenty for this system. And of course it was in the green, so let's go shut it off. Okay, so what that test told me was that the system has ample Freon in here to run, and we likely have a problem with this switch back here. Not to beat a dead horse here, but I really just want to make sure that you know, keep it brief if you're gonna jump the wire, because you can cause damage to your compressor if you don't have any refrigerant or a lubrication in the system. So keep it brief, just long enough to hook up that gauge. You saw I had 40 PSI, it was in the green, that looked okay. So now that we know the Freon's not an issue, it sounds like we likely have an electrical problem. Let's keep going a little further. Our problem is with our low pressure cycling switch. And in all actuality, I did this test over the weekend. Today's, let's see, it's Thursday, and it just took Napa that long to get the part in. So a replacement switch for this truck at least is part 207417. It's a Napa brand interrupter. So anyway, there's not a lot to it. It's just this little switch. Comes with this nice little rubber on the bottom. So that is going to screw in to where our low pressure switch was back there. Now, no, it has a hex on the bottom, makes it pretty easy to screw out. And it's difficult to see, but inside there, you can see there's a little dimple that's sticking out. So a lot of people that I've read question, can you just unscrew this switch, or will it release all the Freon out into the air? Not only is that harmful to you, but I believe it is illegal. So if that's the case, and that's the way your car is, then you need to take it to a shop, have them evacuate the system, and either have them do this job, or you can have them evacuate it, you can do it, and then have them recharge it. In this case, this has what's called a Schrader valve, which is basically a ball valve with a spring on the bottom, is my understanding. So as you unscrew this, that dimple pulls up, which lets the pressure on that spring come up, and then that'll seal all of your Freon inside. As you screw the new one down, it'll press down on the ball valve, releasing the Freon into the switch, and the switch will do its job. So in this case, this one should have it from everything I've read. We're just going to unscrew that one, screw this one right in. No problem. And also, it comes with a little gasket, a little green gasket. I'll show you where to put that in just a second. Okay, with our low pressure side still unplugged, if you look right back up in here, this is the switch that we're replacing. I know it's a little difficult to see, but 11/16" wrench fits the new one. It has this hex at the bottom. It looks like it fits the old one too. Oh, and that's coming out very easily. You can hear it did release a little bit of pressure right there, but sealed up just fine. So this is our old switch. This is from 1997, so probably about time to be replaced. Do you remember that gasket I told you about? If you look down here on the fitting where it comes out, there's this little orange gasket. That is what we're going to be replacing with the new one. Focus for me. There it is. There's a good view of it. So we're just going to take that one off, put the new one on. Okay, our new gasket is mounted up there. You can see it's green, the orange one we took off, and it doesn't need to be all the way down to the base of this fitting. It just needs to be down to the bottom of the threads. So here's our new switch, hex side down. Should screw on here rather easily. Yep. Now that our switch is put back in there, all you need to do is reconnect to all your harnesses, make sure everything's tight, and let's go see if the AC turns on. Now, just keep in mind, before I went ahead and installed that switch, I turned the truck off. It wasn't running, but I had the key on. Just turn that back off. It doesn't need to be on. Just cut all the power, get everything plugged back in, and then we'll just go test it from there. Okay, there you have it, folks. The switch has been installed. I put this shroud back on, made sure everything was plugged back in. I came into the truck here, obviously turned it on. You're going to want to put it on max AC, all the way to cold, the fan all the way on high. And you'll see, with that new switch in here now, that compressor right down there is spinning. So that's all that it needed. We had plenty of Freon in the system. It's just our switch was bad, our cycling switch, and it wasn't telling the compressor to turn on. So that's been running for a little while, been turning, and our air conditioning is coming out nice and cold, just like it should. And that's a wrap on my F-150. We now have cold air coming out of the vents. I really appreciate you guys tuning in, and we'll see you again soon for more projects.